Okay, we are going to explain what a load calculation is. Okay, so we use this form. Okay, so a load calculation. You're going to calculate the load on the house. Think of the load meaning the pressure or the heat or the cool that the outside elements are forcing on the house. Okay, and basically, you know, how the house does. So when Chad goes out, he may complete one of these. It's a comfort survey and home analysis for our customers. So sometimes he'll go through the survey, you know, like what's most important to you, or are you concerned about price? Are you concerned about comfort, clean, usability? So anyway, here's where he draws the house. Okay, so this is the kind of stuff that I used to do, and you draw the house. So to do the load calculation, he is going to measure each room. He has to measure each window, and once he has done that, he also, in the windows, he's going to have to put whether the windows are facing north, south, east, or west. He's got to count the doors, measure the doors. All of these things are going to matter. So then this is the calculation when you think of load calculation. Okay, so here's where he's putting all the doors and where they face, or the windows and where they face. And then they have to be multiplied by a certain number, and that's where we're getting our heat gain, okay, and what, you know, kind of what heat they are letting in, okay. Let's see here. So the heat that they're, so think of it this way, it's the heat that they're letting in, and this is for the cooling load, all right. What's the cooling load, or what is it going to take for that air conditioner to fight against all this heat gain through, you know, the cracks and things also in the house. So square footage of the walls, you're gonna look at the ceiling, and then you have to answer certain questions about like the insulation right here. You have to ask the customer, when's the last time you insulated your attic? How deep is the insulation? Now he's gonna figure out what's called a heat loss. So this is your heating load. You're gonna try to heat the house, but it's losing heat. It's losing heat out the windows and out the door and out through the insulation and all of that. So you have to figure in the same way what's going on. What's the framing made out of? What are the walls made out of? So also the insulation, okay? Is it on a basement? Is it on a concrete slab? Is it on, crawl space? Is there carpet? Is it hardwood floor? All of that stuff is going to matter. Once he's done, he's going to total up all of this. Okay, so if you are looking at an 80% furnace efficiency loss, see at the bottom, you multiply everything times 0.25, and you're going to get a BTU, total BTU input needed. You're going to get that total BTU heat gain. When you're looking at this number, easily your calculations, once you do all of this, you know, it could, kind of what Dad was mentioning before, end up with 47,821. So if we end up with a 47,000, blah, 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 is our big number. Remember when we looked out there at the furnaces, and we generally have them in 60,000 BTU, 80,000 BTU, 100,000 BTU. So if their total ends up being 47,000 and some change, we're going to put a 60,000 BTU furnace in there. So especially if we're going to do a 90% furnace, you're not going to lose a whole lot. Okay, so a 90% furnace or a 95% efficiency furnace means, so think of 95%, we're only losing 5% of the heat that the furnace is putting out. So, you know, your furnace is obviously putting out 100%, but because your house leaks, or because of the it's more the efficiency of the furnace. It's going to put out what it's going to put out, but what's going to go up through that flue. Okay, so the older furnaces, the flue was metal and it was actually warm. You literally were losing heat going up through the flue. Now that they're more efficient, the flues are plastic because they condensate, and so the air going out the flue now, that's that plastic PVC, it is cooler air. We're getting 95% of the heat to stay in the house, and now what we're just losing is carbon monoxide and water. So anyway, this is where then it's decided on what size should we do. So here, this is what's interesting. What your cooling load numbers may end up looking like is, say the total here was 22,000 or 19,000. Well, remember we looked at those the BTUs on an air conditioner in 12s. So if it says something like 19,000, well, it's probably going to take a 2-ton air conditioner, because remember the 2 tons are 2 12s, which is a 24,000 BTU, 24. Well, this, maybe says that it needs 19,000. Well, that's fine. We'll do the 24. And this is something that when you do this on a house, beyond a shadow of a doubt exactly what the house needs. There's no guessing. Okay? So this just has more questions about the house, but if you're doing a boiler, different things like that. It also explains some of the thing with the furnaces is like a horizontal. Sometimes people will have a furnace that runs sideways in their crawl space. Not very often. So, okay, that's it.